Hello lovely people, welcome to another video where we will be looking at straight line equations, y equals mx plus c, all of that good stuff. But with these questions as well, we'll be looking at more exam style questions where they mix different topics together. I think a lot of the times people can answer questions in isolation, so if you're asked one thing and one thing only, people kind of know what to do. However, when topics start to become mixed and lots of different things are asked, that's when things start to get difficult. So we'll be looking at straight line equations, the y equals mx plus c stuff. We'll be also looking at parallel and perpendicular lines, distance between 2 points, which uses Pythagoras' theorem, midpoints, intersections of lines, which means solving simultaneous equations, and rearranging formulae or changing the subject. We'll have a look at quite a few different questions and you'll get an understanding of a mix of how some of these questions work, and hopefully you start to get a pattern. I encourage you to try the question alongside with me so that you have a chance of trying it, thinking for yourself, and then seeing how I might do the question. Some of these questions will have multiple ways of doing things. So if you have a method in which you're doing, maybe post it in the comments and then we can discuss as well. But I'll be following particular methods, but it's not the only methods that you could use. So let's go on to our first question. So we have question A. You are given the equations L1, y equals 2x plus 1, and L2, x plus y equals 10. Part 1 says, find the point of intersection of L1 and L2. So with a question like this, when you're asked to find the point of intersection between two equations, we are solving simultaneous equations, okay? So the two equations are y equals 2x plus 1, x plus y equals 10. I'm actually going to use substitution for this one. So this equation is L1 and then this second one is L2. So what I'm going to do is so for part 1, I'm going to sub, I'm going to sub y equals 2x plus 1 into L2. Okay, so what that means is I can see that y equals 2x plus 1 and L2 says x plus y equals 10. So instead of writing x plus y, I'm going to put x plus this y, which is 2x plus 1. So I'm just going to make that very clear. This is the other version of y, which I'm putting into here. And that is going to equal 10. Now, just simplifying this, I have x plus 2x plus 1 equals 10. 3x plus 1 equals 10. Subtracting 1 from both sides, I get 3x equals 9. Dividing by 3, I get x equals 3. Okay, so we've worked out what x is. Now we also need to work out what y is. So I'm going to sub x equals 3 into, which equation am I going to use? I like the look of L2 better than L1. It seems easier, so I'm going to substitute it there. So into L2. So we have, rather than writing x plus y equals 10, I'm going to replace x with 3. 3 plus y equals 10. Okay? And then, from that point onwards, I'm going to subtract 3 from both sides, getting y equals 7. We're not done. Now that we've got x equals 3, y equals 7, the point of intersection, we need a coordinate. So our coordinate is going to be x, which is 3, and y, which is 7. So 3, 7 is our coordinate. That is the answer for part 1. Okay? Right, now for part 2. Let's go on to part 2. So part 2 says state the gradient and y-intercept of each line. So with L1, we've got y equals 2x plus 1. Now, in the form, when we have y equals mx plus c, m is the gradient, c is the y-intercept. So in this case, the gradient equals 2, and the y-intercept is equal to 1. Now for the other equation, L2, we have x plus y equals 10. But to be able to state the gradient and the y-intercept, it needs to be in the form y equals mx plus c. So we're going to subtract x from both sides, leaving us y equals 10 minus x. Now, a nicer way to write this is actually y equals minus x plus 10, so that we can see exactly what's going on. And just to make it extra clear, there's no number written in front of the x, so we can see there's an invisible 1. So we're going to write it like this. Y equals minus 1x plus 10. Now, it's in the form y equals mx plus c. So that tells us that our gradient for this one is equal to minus 1, and the y-intercept is equal to 10. Okay, now let us go on to part 3. It says, are the two lines parallel, perpendicular, or neither? So for L1, we already got that the gradient is equal to 2. And for L2, the gradient is equal to minus 1. Now, if two lines are parallel, it means the gradients are the same. So the gradients are not the same, so we know it's not parallel. If the two lines are perpendicular, then the gradients are negative reciprocals. Okay? So the negative reciprocal of 2 is, well, first of all, the reciprocal of 2 is a half, and then we change the sign. The negative reciprocal of minus 1 is actually just going to be 1. So they're not negative reciprocals of each other, so they are not perpendicular. Okay? So that being said, they're not parallel, they're not perpendicular, so the answer is neither. Cool. Moving on. Let's just make that a little bit more satisfying. Okay, cool. So part 4. Calculate the distance between the point of intersection and 0, 0. So the point of intersection is 3, 7. It's the part that we worked out in part 1. The answer we worked out in part 1. And 0, 0. So this is where we're working out the distance between 2 points. Just to highlight this a little bit more clearly, let me draw a little coordinate system, set of coordinates. I've got 0, 0 as a point here. And then I've got the point 3, 7. So across 3, up 7. So something roughly there. 3, 7. Just to visualize this. Let's draw a straight line. And then let's connect a line here and here. So to go from the x-coordinate 0 to the x-coordinate 3, I've gone across 3. So the length of our right-angled triangle that we've created is 3. And then to go from the y-coordinate 0 to the y-coordinate 7, I've gone up 7. So we've got a triangle, a right-angled triangle with side lengths 3 and 7. And to work out the final distance, let's call that c, we've got, well, 3 squared plus 7 squared equals c squared, using Pythagoras' theorem. 9 plus 49 equals c squared, and that is 58 equals c squared. So c equals the square root of 58. I'm just going to leave it like that as an answer. We've not been asked anything more. If it were a calculator paper and they asked to work it out to one decimal place or something like that, you could use a calculator. I'm just going to leave it like that. So that's the first question out the way. Let's move on to the next question. Two straight lines are defined by, we have L1 and L2, and it says rearrange L1 into the form y equals mx plus c. Okay, great. So we've got L1, which is in the form 3x minus 4y equals 12. We're going to rearrange this to make y the subject. Okay, so we've got 3x minus 4y equals 12. Let's subtract 3x from both sides. So that gets minus 4y equals 12 minus 3x. Okay, let's also divide both sides by -4. So we have y equals 12 over -4. And then we have minus 3x over -4. Now, this doesn't look the nicest, so we're going to simplify things just a little bit. So, first of all, 12 divided by -4, well, that's just -3. Then we have minus 3/4 x. Looks a lot nicer, and I'll explain why. So that's y equals -3. Two negatives there, we have a plus 3/4 x. And then, because it's asking us in the form y equals mx plus c, let's put the x first. So we have y equals 3/4 x minus 3. Just be very careful when it comes to the rearranging. Okay? So that's what they've asked us to do. I mean, if they were to ask us some follow-up questions like the gradient and y-intercept, we could do that. They haven't asked us, so we're not going to do it just yet. That's the final form, so we are good. Part 2. Determine the gradient of L2 if it is perpendicular to L1. Okay, so L2 has equation y equals mx plus 7. Okay, so if the gradient is going to be, well, if L2 is going to be perpendicular, so they're saying if L2 is perpendicular, determine the gradient of it. Well, L1, first of all, it's y equals, let's just write that a bit more clearly. So it looks like L1. That is y equals 3/4 x minus 3. So the gradient for L1, the gradient for L1 is equal to 3/4. Okay, now, if L2 is perpendicular, that means we take the negative reciprocal of 3/4, which is equal to, so reciprocal of 3/4 is 4/3. We change the sign, becomes minus 4/3. Okay? So, now for L2, that means the gradient of L2 equals minus 4/3. So basically, m is equal to minus 4/3. Okay? So I'm just going to, they haven't asked us to do this, but I'm going to write out the equation for L2. This is the final answer for the gradient, but I'm just going to write out the equation of L2. It's y equals minus 4/3 x plus 7. Okay, that's that question done. Let's go to the third question. If L1 and L2 intersect, find the coordinates of their intersection. So we have the L1 is equal to, well, L1 is the equation y equals 3/4 x minus 3. And for L2, we have the equation y equals minus 4/3 x plus 7. Again, to find the intersection, it's to solve simultaneous equations. I'm going to go by substitution. So sub L1 into L2. Then, well, if they're both y, then we can just make the two things equal to each other. So that's great. So because y is equal to one thing, y is equal to something else, those two things must equal each other. So we can say that 3/4x minus 3 is equal to minus 4/3x plus 7. Okay, so what I'm going to do is take everything with x's on one side and everything without an x onto the other side. So adding 4/3 x to both sides, because we've got this minus 4/3 x, we end up with 3/4 x minus 3 plus 4/3 x is equal to 7. Adding 3 to both sides, because of this minus 3, we get 3/4 x plus 4/3 x equals 7 plus 3, which is 10. Now I just need to add these x's together. So 3/4 x plus 4/3 x. Well, basically, I need to do 3/4 plus 4/3. So let's just do that really quickly. They need the same denominators. So multiply this by 3, multiply this by 3, multiply this by 4, multiply this by 4. Really, really quickly here. So that becomes 9/12 plus 16/12, which equals 25/12. Happy days. So this now becomes 25/12x is equal to 10. Then to get x by itself, I'm going to multiply by 12 because it's divide by 12 and then divide by 25. So x is equal to 10 multiplied by 12 because that's the inverse of the divide by 12, and then divide by 25 because the 25 is being multiplied, which gives us 120/25. That can simplify dividing both sides, both top and bottom by 5. That's going to give us 24/5. Great. So x is 24/5. We now need to work out what y is. Okay? So we sub x equals 24/5 into, let's substitute that into, does it matter? I guess I'm going to pick L1. 3/4 seems easier to work with than minus 4/3, so I don't know, I prefer that. So we have y equals 3/4 of 24/5, because the equation L1, just to remind us, was y equals 3/4 x minus 3. So that's that here. And then, so that's y equals 3/4 of x, which is 24/5 minus 3. 3/4 times 24/5. Well, doing some simplifying here, so divide by 4, I get 1. Divide by 4, I get 6. This is cancelling fractions. Then we have 3 times 6 is 18. Over 1 times 5 is 5. Minus 3. 3 is the same thing as, if I put that as 3/1, I can write that as 3 times 5 over 1 times 5, leading us into 18/5 minus 15/5, which is 3/5. So y is equal to 3/5. Okay? So that means then the coordinates are x is 24/5 and y 3/5. So that's our coordinates. Okay? Happy days. So that was just solving a simultaneous equation. Next, we have part 4. Find the equation of the line parallel to L2 that passes through the point 2, 5. So, first of all, just an equation of a straight line is of the form y equals mx plus c. And if it's going to be parallel to L2, that means it's going to have the same gradient as L2. Well, we already know from a previous part of the question, the L2 had gradient minus 4/3. So we have y equals minus 4/3 x plus c. And it goes through the point 2, 5. So it means that we sub x equals 2, y equals 5, because it goes through those points, and we can use that to work out what c is. So we have 5 equals minus 4/3, lots of 2, plus c. So 5 equals minus 4/3 times 2, so that's times by 2/1, plus c. 5 equals, well, that's minus 8/3, plus c. And then we have 5 plus 8 over 3, just adding 8 over 3 to both sides is equal to c. To add these fractions, we have 5 over 1 plus 8 over 3. And then multiply by 3, multiply by 3 to give the same denominators. And then that gives us 15 over 3 plus 8 over 3, which equals 23 over 3, which equals c. So the final equation is y equals minus 4 thirds x plus 23 over 3. Okay, so that is these two questions. If you want to see more of this stuff, then have a look at the part 2 of my video, where we'll look at 2 more questions, because these questions are quite tough and challenging. I'm going to keep up the series, then that way you'll be able to see how we do quite a few of these types of questions. But these are the kinds of questions that really challenge people, not really because each individual thing, every single thing that you're doing is challenging, but it's because there's a lot of moving parts. When there's lots of moving parts, that's what can get quite challenging for a lot of people, especially when you're learning things in isolation. Anyway, I will see you in part 2. Take care for now.